Hello, everyone. This is Dr. Prato. Thank you for coming to class today. Today, I would like to show you how to add expressions with radicals. So you see here, this is -3 times the square root of 7 plus 4 plus times the square root of 7. Now, in situations like this where we can't reduce what's inside the radical, um, this is no different than taking something like -3x and adding 4x to it. See, x is now taking the place of root 7. So what's -3x plus 4x? Well, that's just x. The same thing goes here. -3 root 7 plus 4 root 7 is just the square root of 7. Oh my, I apologize. This is square root 7. So you see how x, which took the place of square root 7, is square root 7. Um, let's talk about this next one. This next one is very similar in that the square root of 17 cannot be reduced. So this is the same thing as something like -3x minus 4x, which is -7x. So the same thing here. This just becomes -7 square root 17. Let's work on a more interesting problem. Here we see square root 3 and square root 27. Now, 27 is a special number because 27 is 9 times 3. So let me rewrite this. And we can also write 27 as 3 to the third power. So we can write this as 3 square root 3 minus the square root of 3 to the third power. Now, what's important here is that we can break up this 3 to the third power into 3 squared times 3. So this is 3 square root 3 minus square root 3 squared times 3. And when we take the square root of 3 squared, this whole term can come out as a 3. So we get 3 square root 3 minus the square root of 3 squared, also known as the square root of 9, is 3. So 3 squared gets to come out as 3. And on the inside is square root 3. So 3 square root 3 minus 3 square root 3. Well, imagine those were x's again. What would 3x minus 3x be? That'd be 0. And so is this. All right, let's look at another problem. Here you have square root 18, square root 12, and square root 18. Can we break these radicals down into their simplest forms? So for example, we know that 18 is 9 times 2. We know that 12 is what? 4 times 3, and 18 again is 9 times 2. So look, we know that 9 is a perfect square root. The square root of 9 is 3. The square root of 4 is 2, and the square root of 9 is 3 again. So let me rewrite this as 2 square root 9 times 2 minus 2 square root 4 times 3 plus 2 square root 9 times 2. So you see here, this 9, the square root of 9 is 3. So this 9 is going to come out as a 3, and it's going to multiply what was ever in front. So make that a, see that 9 comes out as a 3. Okay, here this 4 is going to come out as a 2. So that 2 is going to stay there, and this 4 is going to come out as a 2. And what's inside is square root 3. And finally here, this 2 is going to stay a 2, but this square root 9 is going to come out as a 3, and the square root 2 is going to stay on the inside. So 2 times 3 is 6, 6 root 2 minus 4 root 3 plus 6 root 2. And as you can see here, we can add like terms. So imagine this is like 6x uh, minus 4y plus 6x. See that? You would add the x's together, you get 12x. and the y would stay by itself. But in this situation, 6 root 2 plus 6 root 2 is 12 root 2, and that minus 4 root 3 stays all by itself. Let's look at a more interesting problem now. Again, here, what we want to do is simplify what's inside the radical. So what does 27? We know that was 9 times 3, right? 45. Well, let's think. 45 divided by 5 is 9 times 5. 20. That's 4 times 5. And again, this is 9 times 5. So let's rewrite this. Minus square root of 9 times 3 minus 3 square root of 9 times 5 minus the square root of 4 times 5 plus 2 square root 9 times 5. So this 9 will come out as a 3, this 9 will come out as a 3, this 4 will come out as a 2, and this 9 will come out as a 3. So we'll have negative 3 root 3 minus. Now remember, when there's anything in front, it's going to have to multiply when it comes out. When this 9 comes out, it's going to come out as this 3 root 5 minus this 4 is going to come out as a 2 root 5. And again, square root 9 is 3, so 2 times 3 root 5. This is minus 3 root 3 minus 6, so whoopsie, minus 9 root 5 minus 2 root 5 plus 6 root 5. And then we look, there's no other square root 3's. There are, these are all square root 5, so minus 9 minus 2 is minus 11 plus 6. That's negative 5. So all three of these terms become negative 5 root 5 minus 3 root 3. All right, I think we're going to call it there. Well, we could do one more problem, actually. This problem here, again, we know that this is 9. We want to simplify this, so this is 9 times 5. This is 4 times 3. This is 2 times 3. See, there's nothing we can really do with that because 2 and 3 are prime numbers. And then this would be 4 times 5. So this would be minus 3 square root 9 times 5 plus 2 square root 4 times 3 plus 3 square root 2 times 3. Again, there's nothing really I can do with that. Minus 3 square root 4 times 5. Now here, this 9 will come out as a 3. So we'll have minus 3 times 3 square root 5 plus 2. This 4 comes out as a 2 root 3. Now here, this has to just say 3 root 6. There's nothing I can pull out. And this will be minus 3 times the 4 comes out as a 2 root 5. So this is minus 9 root 5 plus 4 root 3 plus 3 root 6 minus 6 root 5. And we see if there's any common terms. These root 5s are the same. So minus 9 minus 6, that should be minus 15 root 5. And see, there's nothing we can do with these terms, so we just have to add them. Plus 4 root 3 plus 3 root 6. A little messy. Then we rewrite that. This should be negative 15 root 5 plus 4 root 3 plus 3 root 6. All right, thanks for coming to class today, everyone. See you next time.